On March 1st, 2026, a drone crossed the Persian Gulf toward Bahrain. It was 3.5 meters long, powered by a piston engine that sounded like a lawnmower cutting grass in the sky. It cost between $20,000 and $50,000 to build, but its target, the ANTPS-59 radar installation at US Naval Support Activity in Bahrain, was worth $300 million. The drone hit it, and while that single Shahed 136 threaded its way toward the 5th Fleet's headquarters, roughly 2,000 more were fanning out across 9 countries in the largest coordinated drone offensive in history. This is the story of how a garage-built aircraft with a wooden propeller became the weapon that rewrote the economics of war. To understand the Shahed 136, you need to go back to a different era entirely. Not to Iran, to West Germany in the early 1980s at the height of the Cold War. The United States and West Germany were working together on a problem. Soviet radar installations along the Iron Curtain were too dangerous for manned aircraft to approach. Both countries needed a way to destroy those radars without risking pilots. The solution was an expendable drone, something cheap enough to throw away, smart enough to find its target, and simple enough to produce in bulk. German aircraft manufacturer Dornier won the contract. They called it Die Drohne Anti-Radar, the DAR. It was a delta wing aircraft about 110 kilograms, powered by a Fichtel and Sachs piston engine driving a pusher propeller. It launched from truck-mounted racks, 6 drones per vehicle. It navigated using GPS. And when it found its target, it dove into it and exploded. If that description sounds familiar, it should, because 4 decades later, the Shahed 136 uses essentially the same formula. A delta-wing airframe, a piston engine driving a pusher propeller, truck-mounted launch racks, GPS guidance, and a one-way mission that ends in an explosion. The DAR was supposed to enter service with the German Bundeswehr in the 1990s. Then the Berlin Wall came down, the Cold War ended. The Soviet radars the DAR was designed to destroy suddenly belonged to a country that no longer existed. The project was shelved, the prototypes ended up in a museum at the now defunct Dornier factory, and 2 launch vehicles were reportedly sold to an unknown buyer in 2009. But the concept did not die. Israel Aerospace Industries developed a similar weapon called the Harpy, an anti-radar loitering munition that looked remarkably like the DAR and operated on the same principle. The Harpy saw real combat in the Second Nagorno-Karabakh War in 2020, where it overwhelmed Armenian air defenses. And somewhere along this chain of technological inheritance, Iran was paying attention. The Islamic Republic had been developing its own drone program since the 1980s, born partly from necessity during the Iran-Iraq War, and partly from the ingenuity that international sanctions forced upon its engineers. By the 2010s, Iran's Shahed Aviation Industries and Haysa, the state-owned aircraft manufacturer, had produced something that took the basic delta-wing Kamikaze concept and optimized it for one thing above all else: cost. The Shahed 136 is, by the standards of military aviation, almost absurdly simple. It is 3.5 meters long with a 2.5 meter wingspan. It weighs about 200 kilograms fully loaded. Its airframe is built from carbon fiber cloth and honeycomb composite material so basic that defense analysts have described the construction process as something a competent do-it-yourself hobbyist could replicate. The engine is an Iranian-made Mado MD-550, a 4-cylinder piston motor that produces about 50 horsepower. It is a reverse-engineered copy of the German Limbach L550E, an engine originally developed for model aircraft enthusiasts and ultralight planes. That German lineage is one of the strange through lines in this story. The original DAR used a German Fichtel and Sachs engine. 40 years later, the drone that inherited its shape runs on a copy of a different German engine built for the same civilian aviation community. The MD-550 drives a 2-bladed pusher propeller mounted at the rear of the fuselage. It gives the Shahed 136 a cruising speed of about 185 kilometers per hour and a maximum range that various sources place between 1,300 and 2,500 kilometers, depending on payload configuration. For navigation, the drone relies on GPS and inertial guidance systems following pre-programmed waypoints to a set of target coordinates. It carries a warhead of roughly 30 to 50 kilograms of explosives. It launches from truck-mounted racks using a rocket-assisted takeoff booster that fires the drone off the rail at an upward angle. Once the booster burns out and separates, the piston engine takes over. The entire launch system, the drone, the rack, the truck, is portable enough to set up almost anywhere, fire, and relocate before anyone can track the launch point. That portability matters. The real advantage of the Shahed 136 is not any single technical specification. It is that Iran can build enormous numbers of them in small workshops distributed across the country using commercial-grade components that are almost impossible to sanction effectively. Estimates of production cost range from $20,000 to $50,000 per unit. Even at the high end, that is a rounding error compared to the weapon systems designed to stop it. And this is where the math gets uncomfortable for the Pentagon and every air defense battery deployed across the Persian Gulf. A single Patriot PAC-3 interceptor missile costs approximately $4 million. A Shahed 136 costs at most $50,000. That means for every successful interception, the defender spends roughly 80 times more than the attacker. Scale that across hundreds or thousands of incoming drones, and the economics become devastating even when interception rates are high. This was not theoretical when Operation Epic Fury began. The cost asymmetry had already been tested on the battlefields of Ukraine. Ukraine became the proving ground. Starting in September 2022, Russia began deploying Iranian-supplied Shahed 136 drones under the designation Garan-2, meaning Geranium-2, against Ukrainian cities and infrastructure. The campaign started with shipments from Iran and eventually expanded to domestic Russian production at the Alabuga Special Economic Zone, where assembly lines were cranking out thousands of units. The attacks on Ukraine revealed something critical about the Shahed 136 that no specification sheet could capture. The drone's low radar cross-section and low altitude flight profile made it genuinely difficult to detect until it was close to its target. Ukrainian soldiers and civilians described the distinctive sound first, a droning, lawnmower-like buzz from the piston engine that became a source of genuine psychological dread. Observers compared it to the sound of Germany's V-1 flying bombs during World War II, another crude but effective weapon that terrorized civilian populations through sheer volume. Ukraine adapted. Its forces shot down Shaheds with everything from sophisticated surface to air missiles to World War II-era anti-aircraft guns. MiG-29 fighter jets were scrambled to chase them. Electronic warfare teams learned to jam their GPS signals, prompting Russia to add new Chinese-made antennas and eventually Starlink satellite connections for remote control. By early 2026, Russia was producing an estimated 6,000 Shaheds per month, more than 200 per day, while the cost per unit had dropped to roughly $70,000, down from nearly $300,000 when Russia first purchased them from Iran. The lesson Ukraine taught the world was simple. You can shoot down most of them. You can even shoot down 90% of them. But the 10% that get through will do damage far out of proportion to their cost. And the missiles you fire to stop them will run out before the drones do. That lesson arrived in the Persian Gulf on February the 28th, 2026. In the early hours of that morning, the United States and Israel launched Operation Epic Fury, a massive coordinated air campaign against Iran targeting nuclear facilities, ballistic missile sites, naval bases, and leadership compounds. The operation involved 2 aircraft carrier strike groups, B-2 stealth bombers flying from Whiteman Air Force Base in Missouri, hundreds of strike fighters, and Tomahawk cruise missiles launched from destroyers across the region. Israel's parallel operation, Roaring Lion, sent approximately 200 aircraft into Iranian airspace in the opening wave alone. Iran's response came fast. The weapon it chose to lead that response was the one it had been stockpiling and refining for years. In the first 4 days of the conflict, Iran launched over 2,000 attack drones alongside more than 500 ballistic missiles. The drones came in waves, coordinated salvos that Iranian state media called successive phases of Operation True Promise 4. They targeted not just Israel, the obvious adversary, but every nation in the region that hosted American military infrastructure. The United Arab Emirates absorbed the heaviest drone bombardment. Open-source data compiled by the Hudson Institute indicated that by March 4th, Iran had directed roughly 189 ballistic missiles and approximately 941 drones toward the United Arab Emirates alone. The United Arab Emirates' layered air defense network, including Patriot, THAAD, and NASAMS systems intercepted an estimated 90 to 95% of incoming threats. That sounds like a success. In absolute terms, it was remarkable. But 21 drones still got through. They struck civilian targets, including areas near Dubai International Airport, where a terminal was damaged and workers were injured. Hotels in Dubai were hit. The Jebel Ali port complex was targeted, and the UAE was just one front in a 9-country war. Kuwait intercepted 178 ballistic missiles and 384 drones. Despite that high interception rate, Iranian drones struck the Ali Al Salam air base repeatedly, triggering major fires. The American embassy in Kuwait was hit directly by drones, and in one of the conflict's most tragic incidents, Kuwaiti Patriot air defense batteries shot down 3 US Air Force F-15E Strike Eagles in a friendly fire incident. The kind of catastrophic confusion that mass drone swarms are designed to create. Bahrain, the smallest Gulf state in the conflict zone and home to the US Navy's 5th Fleet, intercepted 70 missiles and 59 drones by March 3rd. The Shahed that struck the radar installation near the naval headquarters in Manama demonstrated the asymmetry problem in its starkest terms. One drone that cost less than a new car destroyed a radar system that cost more than most skyscrapers. Qatar reported detecting over 100 ballistic missiles and dozens of drones. Saudi Arabia saw strikes against the Aramco refinery at RAS Tanura, one of the most important petroleum facilities in the world. Jordan was targeted. Iran even struck infrastructure in Azerbaijan after drone attacks hit Nakhchivan International Airport, drawing Azerbaijan's military to its highest alert level. In total, Iran's retaliatory campaign hit targets across 9 countries simultaneously. The geographic scope was unprecedented. Take a step back from the individual strikes, and what emerges is a pattern. Tehran was waging a campaign designed not to defeat these nations militarily because it could not, but to impose costs so severe that the coalition supporting Operation Epic Fury would fracture under the economic and political pressure. The drone attrition trap was working exactly as designed. The attrition was deliberate. Consider the interceptor math. The United States and its Gulf partners were expending Patriot PAC-3 missiles at rates their production lines simply could not sustain. Current monthly PAC-3 production was estimated at roughly 50 to 60 units. Iran was launching hundreds of drones in single waves. Even with high interception rates, the stockpiles were finite and shrinking fast. Analysts at the Atlantic Council warned that while depletion was not imminent, it remained an urgent issue, particularly as attacks from Hezbollah in Lebanon and other Iranian-backed groups opened additional fronts that stretched defensive resources even thinner. And this is where the story takes its most ironic turn. In a hangar at a US military base somewhere in the CENTCOM operating area. On February the 28th, the same day Operation Epic Fury began, US Central Command made an announcement. Task Force Scorpion Strike, a newly formed unit under Special Operations Command Central, had conducted the first ever combat deployment of a weapon called Lucas, the low-cost, uncrewed combat attack system. Lucas is, in every meaningful sense, a kamikaze drone. It has a delta wing shape, a pusher propeller. It is ground-launched from mobile platforms, and it is priced between $30,000 and $35,000 per unit. Lucas is a reverse-engineered copy of the Shahed 136. The drone was developed by SpectraWorks, a small company based in Arizona, starting with captured Iranian drones that had been recovered from battlefields in Ukraine and the Middle East. Admiral Brad Cooper, the CENTCOM commander, put it bluntly at a press conference, saying that this was an original Iranian drone design. We captured it, pulled the guts out, sent it back to America, put a little Made in America on it, brought it back here, and we are shooting it at the Iranians. The full circle is almost too perfect to be real. A concept born in a German defense lab in the 1980s, shelved when the Cold War ended, possibly inherited by Israel, definitely perfected by Iran, tested by Russia against Ukraine, and now cloned by the United States to fire back at its creator. The Delta Wing Kamikaze drone has become something like the AK-47 of aerial warfare. A design so simple, so effective, and so cheap that every major military power on Earth has concluded it needs its own version. Lucas does have upgrades over the original Shahed. It uses vision-based object recognition rather than relying solely on GPS coordinates, which theoretically reduces collateral damage. It offers modular capability, meaning a single airframe can serve as an explosive munition, a sensor platform, a jammer, or a communications relay. And it features what CENTCOM describes as advanced autonomous swarm coordination. the ability for multiple Lucas drones to operate as a networked group rather than individual weapons flying to individual coordinates. But the fundamental logic behind Lucas is the same logic that built the Shahed. Make it cheap enough to throw away and build so many that no defense system can keep up. The Pentagon's own drone dominance program is built on the recognition that in the conflicts of the 2020s, the side that can mass-produce disposable weapons faster may control the battlefield outcome, regardless of which side has the more sophisticated technology. That recognition represents a profound shift in American military thinking. For decades, the US doctrine was built on the assumption that quality defeats quantity. One F-35 stealth fighter at $80 million could dominate a battlefield that 1,000 lesser aircraft could not. One Patriot battery could shield an entire military installation. The American way of war was defined by precision, by technology so advanced that no adversary could match it. The Shahed 136 did not match it. It did not try to. It just changed the question. Instead of asking which weapon is more capable, it asked which weapon can be built faster, lost more easily, and replaced more cheaply. And against that question, the world's most expensive military found itself at a structural disadvantage. None of this means the Shahed 136 is a wonder weapon. It flies slowly, it makes a tremendous amount of noise, and it can be shot down by systems far less expensive than a Patriot missile, including electronic warfare, close-in weapon systems, and even coordinated small arms fire. Ukraine proved that dedicated counter-drone defenses can dramatically reduce the Shahed's effectiveness. The United Kingdom deployed experienced Ukrainian counter-drone operators to the Gulf within days of the conflict's start, bringing hard-won knowledge from years of defending against the same weapon. And Iran's ability to sustain mass drone production is not unlimited. US and Israeli strikes during Operation Epic Fury specifically targeted storage depots and manufacturing sites for the Shahed 136. Destroying centralized stockpiles disrupts the operational tempo, even if decentralized workshops can eventually rebuild. The question is whether that disruption happens fast enough to matter. What the Shahed 136 has demonstrated, though, is something that defense planners will be studying for decades. In an era where a single engineer in a small workshop can assemble 12 drones in a 10-hour shift, and where each of those drones forces the defender to choose between spending $4 million to shoot it down or accepting the damage it will cause, the old calculus of military superiority no longer holds. The drone sitting in a museum at the former Dornier factory in Friedrichshafen, Germany, the one that was never built in numbers, never deployed, never fired in anger, turned out to contain the blueprint for a weapon that would reshape warfare 40 years after its creators abandoned it. Sometimes the most consequential weapons are not the most expensive ones. Sometimes they are the ones simple enough to build in a garage. If you found this breakdown useful, subscribe. I cover the technology and strategy shaping modern conflict every week.